Hello, welcome to the course on microengineering. Dear students, in the last video lecture, we have discussed about gun diode, and if you recall, then basically gun diode is solid state semiconductor device which is fabricated from the single N-type material. It does not have any PN junction and it exhibits negative resistance in its VI characteristics, and because of this it is widely used as a oscillator. Now in today's class we will going to discuss about another solid microwave component which is the pin diode. So basically this pin diode is advancement of our normal PN junction diode. So if you recall, in our normal PN junction diode, there are only two layers. One is P, another is N. But here there are three layers, in which we have one more layer which is known as an intrinsic layer between P and N type. Okay, तो PN junction diode में basically क्या होता है कि एक P layer होता है, दूसरा N layer होता है. Like this. This is the P layer. This is the N layer. So this is our normal PN junction diode. But in case of this pin diode, we have one more layer in between this P and N, which is known as an intrinsic layer. Okay. So if we look at the construction, basic construction of pin diode, then there are three layers. One is P, another is intrinsic layer, and there is a N layer. Okay. So basically it has a three layer. One is P, intrinsic layer, and N layer. Correct. So this is the P layer, this is the intrinsic layer which is basically termed indicated by I, and this is N. Hence it is known as a pin diode. And this, very important to note, this intrinsic layer is basically undoped semiconductor, okay, which is sandwiched between P and N region, and thus making the pin diode. Okay, and the presence of this intrinsic region exhibit the high resistance property of this pin diode. Okay, because ये intrinsic layer है और जैसे यहाँ पे मेंशन किया कि वो अनडॉप्ड सेमीकंडक्टर है, तो अनडॉप्ड सेमीकंडक्टर में वैसे भी कंडक्टिविटी कम होती है. इट मींस दिस रीजन, इंट्रिंसिक रीजन, exhibit high resistance property. Okay, and because of this the magnitude of the electric field also become very large. Okay, and because of this high electric field, it will resultantly increase in the electron hole pair generation in this region. Okay, so basically one of the things that we noted, that presence of intrinsic region provide high resistance in this device. Along with providing high resistance, the pin diode also provide the lower value of the capacitance. मतलब वो रेजिस्टेंस तो प्रोवाइड करता है एज वेल एज लो वैल्यू ऑफ कैपेसिटेंस भी प्रोवाइड करता है. सो हाउ इट इज प्रोवाइड द लो वैल्यू ऑफ कैपेसिटेंस? सो अकॉर्डिंग टू द, इफ यू रिकॉल द फॉर्मूला फॉर द कैपेसिटेंस, देन कैपेसिटेंस फॉर्मूला C इज इक्वल टू एप्सिलॉन नॉट इंटू एप्सिलॉन R A डिवाइडेड बाई D, वेयर एप्सिलॉन 0 और इज द फ्री स्पेस परमिटिविटी, एप्सिलॉन R that is a relative permittivity, A is the area of the plate, and D is the distance between two plates. So how this pin diode provide the low value of capacitance? So basically if you look at the structure of capacitor, then in capacitor there are two metal plates separated by dielectric material. Okay, so here also in pin diode, this P material, it act as a one of the plate, N material act as a another plate, and there is a intrinsic layer which act as a dielectric, hence it provide the capacitance value. So with the insertion of intrinsic region, the distance between plate P and N region increase. ये दोनों के बीच में distance increase हो गया. Okay, and from the above expression it is clear that the capacitance and distance are inversely proportional. So with the increase in the distance, the capacitance will decrease. Correct? समझ में आ गया? Okay, so basically ये intrinsic region की वजह से it exhibit the capacitive effect. ओके, और जितना सेपरेशन दो प्लेट के बीच में बढ़ेगा उतना कैपेसिटेंस डिक्रीज होगा. So we can say that pin diode provide high resistance as well as low value of capacitance. Okay, so if you look at the symbol of the pin diode, then its symbol is almost similar to our normal PN junction diode. It has two terminal, one is anode, another is cathode. And जैसे मैंने explain किया कि there are two region P and N. In between P and N there is a intrinsic region which is the high resistivity region or low conductivity region because it is the undoped region. Okay, correct. So the basically this is the undoped region or doping level is very low in intrinsic region, where P and N material has the highly doped region. So they are basically denoted by P plus region and N plus. Okay, so the reason behind P plus and N plus is basically the doping level of these two region is higher than the doping level of intrinsic region. Correct. Now if you look at the working of pin diode, then we can understand the working of pin diode by considering three different cases. Okay, so we will discuss three different cases to understand the working of pin diode. One is the under zero bias, forward biasing and reverse biasing. So basically working of this diode is almost similar to our normal PN junction diode, but there are some difference exists because of this additional intrinsic layer. And basically if we recall, then our normal PN junction diode is basically used as a rectifier, but this pin diode is not widely used as a rectifier, but it is widely suitable for switching purpose and attenuators. Okay, so pin diode is basically used for high frequency switch. Now we will try to understand the working of this pin diode considering three different cases. First case is under zero bias. So zero bias means no voltage or no external potential is provided to the diode. So if we give the zero bias to this PN junction diode, then carrier will diffuse across the junction because of the concentration gradient. Okay, मतलब कि concentration gradient का मतलब होता है कि एक जगह पे कैरियर का concentration ज्यादा होता है, दूसरी जगह पे कैरियर का concentration कम होता है. And because of the difference in the concentration in two region, the charge will flow from higher concentration to lower concentration, and उसको हम बोलते हैं concentration gradient. And because of the concentration gradient, the carriers will diffuse across the junction. And because of this, because of diffusion of the carriers across the junction, the depletion region is formed at the Ni junction. Ni junction means N और intrinsic के बीच का जो junction है उसको हम बोलेंगे Ni junction. This is the Ni junction. This is the Pi junction. This is the Ni junction. This is the Pi junction. Okay, and very important to note, the thickness of the depletion layer is greater in I region as compared to N region, because the doping level of the N region is higher than the doping level of intrinsic region. तो यहाँ पे I टाइप के मटेरियल में, इंट्रिंसिक मटेरियल में डिप्लेशन लेयर की थिकनेस ज्यादा होगी कंपेयर टू N region. Okay, and this is so because the doping level of N region is very much higher than the intrinsic region. Okay, because हमने देखा था कि इंट्रिंसिक रीजन तो अनडॉप्ड सेमीकंडक्टर और ये डॉप्ड सेमीकंडक्टर है, तो एन रीजन का डॉपिंग लेवल आई रीजन के डॉपिंग लेवल से ज्यादा होगा. तो सिंपल है कि अंडर जीरो बायस व्हाट विल हैपन, ओनली द डिप्लेशन लेयर इज फॉर्म एट द Ni junction, and the depletion layer is formed because of the diffusion of carriers across the junction because of the carrier concentration gradient. Okay, now let's look at about the another condition, which is the forward bias condition or forward bias operation of the PN diode. So whenever PN diode is subject to the forward bias, the depletion layer at the PN junction reduce, है ना. जैसे नॉर्मल PN जंक्शन डायोड में होता था कि फॉरवर्ड बायस हम जब देते थे तो जो डिप्लेशन लेयर की जो विड्थ है वो डिक्रीज होती थी. तो सिमिलरली हियर आल्सो इन पिन डायोड, व्हेनेवर वी अप्लाई द फॉरवर्ड बायस, द डिप्लेशन लेयर और डिप्लेशन रीजन एट द PN junction will reduce. Now what do you mean by the forward bias? Forward bias means the p-type material is connected to positive terminal of the battery, n-type material is connected to the negative terminal of the battery. Okay, and if the width of the depletion region is reduced, then resistance offered by the device is also decreased as compared in the no bias condition. मतलब नो बायस कंडीशन में जो रेजिस्टेंस डिवाइस ऑफर करता था, इसके कंपेयर में फॉरवर्ड बायस में रेजिस्टेंस डिक्रीज हो जाएगा. ओके, सो एज वी इंक्रीज द फॉरवर्ड बायस, द ग्रेटर नंबर ऑफ चार्ज कैरियर्स गेट इंजेक्टेड इनटू द इंट्रिंसिक रीजन and thereby producing the large current through the device, and ultimately we can say that the resistance of the device decrease. ओके, तो मतलब क्या हुआ कि जैसे हमने फॉरवर्ड बायस दिया, the resistance of the device is reduced. So we can say that in forward bias condition, pin diode behaves as a variable resistance device because device का resistance change हो रहा है with the variation in the forward bias voltage. Hence it is known as a variable resistance device. Okay, so we can say that under forward bias, pin diode behaves as a variable resistance device or variable resistor. Correct? Okay, तो simple है. Under forward bias condition, the width of the depletion layer reduce, and if the width of the depletion layer is reduced, then conductivity of the device is increased, and if the conductivity increase, then resistivity decrease, or resistance offered by the device is decreased. Hence we can say that under forward bias, the device behaves as a variable resistance device. Now let's understand what will happen under reverse bias operation of the PN junction diode. So basically, as the reverse bias voltage is applied to the device, the depletion region width start to increase. Depletion layer की width increase हो जाएगी, and as the reverse voltage increase, the width of the depletion layer is increased as far as whole mobile carrier swept away from the intrinsic region. करेक्ट, मतलब हम रिवर्स वोल्टेज इंक्रीज करते जाएगी और विड्थ ऑफ द डिप्लेशन इतनी इंक्रीज हो जाएगी कि मोबाइल कैरियर्स इंट्रिंसिक रीजन से स्वेप्ट आउट हो जाएंगे. एंड द वोल्टेज, द रिवर्स वोल्टेज एट विच दिस विल हैपन इज नोन एज अ स्वेप्ट आउट वोल्टेज. करेक्ट, फिर से अगर हम रिवर्स वोल्टेज इंक्रीज करते जाएंगे, देन विड्थ ऑफ द डिप्लेशन लेयर इज इंक्रीज, एंड विड्थ ऑफ द डिप्लेशन लेयर इंक्रीज. एक ऐसा स्टेज आएगा कि होल मोबाइल कैरियर्स आर स्वेप्ट आउट फ्रॉम द इंट्रिंसिक रीजन, एंड द पर्टिकुलर वोल्टेज एट विच दिस हैपन्स इज बेसिकली नोन एज अ स्वेप्ट आउट वोल्टेज, एंड यूजुअली टिपिकली इट्स वैल्यू इज -2 volt. ओके, एंड as I mentioned earlier, the device function as a capacitor in the reverse bias condition. Okay, because दो जो p type material n type material है, they will serve as a two plates of the capacitor. An intrinsic layer which is a swept out region, is basically act as a dielectric. It will act as a dielectric. Correct? And in reverse bias, this will behaves like a low value capacitor. Okay, so if we conclude this working of pin diode, then under forward bias the pin diode behaves like a variable resistance device, and under reverse bias it behaves like a low value capacitance device, low value capacitor or capacitor. Now what are the applications of pin diode? So these diodes are basically used in RF and microwave switches and microwave variable attenuators. These diodes are effectively used for radio frequency protection circuit, and it can also be utilized as a RF switch. They are also used in the photodetector and photovoltaic cell and the pin photodiode, which are used in the optical fiber network, cars and also switches. ओके, मतलब ये ऑप्टिकल कम्युनिकेशन में एज अ फोटो डिटेक्टर एंड फोटो डायोड की तरह वो यूज होता है. ओके, सो आज के लेक्चर में हमने क्या डिस्कस किया? सो इन टुडेज क्लास वी हैव डिस्कस अबाउट दी वन ऑफ दी सॉलिड स्टेट माइक्रो डिवाइस विच इज द पिन डायोड, एंड बेसिकली पिन डायोड इज ऑलमोस्ट सिमिलर टू दी अवर नॉर्मल पीएन जंक्शन डायोड. ओनली डिफरेंस अराइज दैट इट हैज 3 layers. One more layer, which is the intrinsic layer, is added to the, or it is sandwiched between the two P and N type material, correct? Okay, and under forward bias condition, this pin diode behaves as a variable resistor device, and under reverse bias it behaves like a capacitor. Okay, and at the end we have discussed about the applications of pin diode. So I hope कि आज के लेक्चर में जो हमने डिस्कस किया आपको समझ में आ गया होगा. Let's stop here. We'll discuss other aspect of this course in our next video lecture. Thank you very much.